Hi everyone, this is a longer tutorial on something what I've been searching or doing research for. So it's about the motion study in different kind of CAD system. Over here we have our SolidWorks assembly file for belt assembly. We have this model assembled for the kinematic drafting classes. And then we apply the belt well, actually, we assemble these parts and then we will create a belt in this assembly. So how we do this is going over to the assembly panel and go to the belt chain. That's where it will give you a property manager like this. So once you are in this property manager, you can select your 3 pulleys. Each pulleys, it will kind of calculate your diameter for you. Over here it will label out, and so we have two pulley and 1 idler, and we will select the plane that's aligned over here, that's in between 2 face of the pulley. Then we'll click on the drive to make our belt length being driving the location of the pulley. So let's say, oops, let's do this. So if we ever change it to maybe 2,500, let it run a little bit, you see how your pulley is changed its location, and we have a longer belt length. So let's go back, change it back to our 2000, and we can adjust our belt thickness over here, and since the belt thickness calculates out the belt length, so it will take some effect to it as well. Yeah, you see how it's kind of doing that tweak. So that's how it goes with generating out our belt in the assembly. So once we have that, we can click OK. It will give you a schematic sketch of the line and also a part, actually assembly file for the belt. And inside that belt, you can adjust, you can edit component, this one, edit part, and to draw out your profile that could sweep around this belt loop. So once you have that, you can render in, or you can show out a more proper schematic of, or you can show out a more proper rendering for this assembly. So, but that's not the point for today because we are going over for our motion. So let's go over to the motion study here. We will select our type of motion to basic motion and apply before that, we have a belt mate automatically generated when we create a belt. We also need to apply a cam mate that's driving the cam, and it will drive the follower. So we have that. We will go over to our rotary motor, and by clicking on this motor icon, you can insert a motor, and it will bring you to here. So this panel, this motor property manage is telling you to select a component that it will rotate, and you can select the shaft edge here and select which direction you want to rotate. Let's give it a better view here. So then once you have that, you can apply a speed. I have reduced the speed to 60, and when we have that anchored in the beginning, we actually have it for 100 RPM. Yeah. So that's that, and you can, once you set up everything, just click calculate and it will run it. I hope, yeah, something is wrong. I think maybe I have a different rotation here. Let's go back. Yeah, sometimes it does that, so you need to do a couple calculation before it actually runs good. So you can go over here, kind of adjust your basic motion frames per second and like how the accuracy for the geometry is. Then let's do the calculation again, hopefully it works. Yeah, this time it's running more smoother. So then when you play, yeah, so that's pretty much it. I am gonna disable the play view so that it's going to my original keyframe for the view on the camera, and when you play it will have a better view on our motion. Yeah, so over here you can change to the playback mode to like loop, and then it will continue on with this rotary motion. But when you click on disable the view playback, it will stay in one view. So that's it. Then when we need to go into the Inventor, we actually need to create more mates. The Inventor have a different kind of setting for their relationships. So there's joints and constraint. When you set it up, it will automatically be put into the dynamic stimulation as standard joint. So those joints, the more you put, the more things you will need to do troubleshooting from. So I only put the components necessary to show the motion in here. So this is Inventor interface with our assembly, belt assembly. And to generate our belt, we need to go over to the design, and here's the V belt. You click on this one, it will bring you to a interface that give you the component generator. Tricky part of this is, like SolidWorks, we have the driving belt length, and it will kind of it will give a certain degree of freedoms on the drives. We don't need to do much of the selection here, but over here we have 3 pulleys. We need to assign the pulleys. The first of pulleys I assigned is existing, so we pick on the large pulley. Then it will, for the existing, if you choose the existing option, it will always give you a constraint that's to the geometry. So that means you don't have any degree of freedoms at all. And so we click on the second one, give a component existing, and then choose the smaller one, and it will constrain automatically to the geometry. Then the third one, if we click on components, and if we click on existing, and then it will automatically be, if we actually have the small one here, we will click onto it, and it will constrain to the axis here. And it doesn't really work because now it's not letting you to generate. See the OK button is being grayed out, and we need to go for component, and it's still not working because this option here is still constrained to a geometry. We need to have it by free sliding position, and it's like this component is generated automatically when you click OK, and you can have like different sizes or something to it. So that will create another problem because we don't know if it's going to be fitting to our small pulley. We can talk about that a little bit later in this video. So we have this one, we have a slider, and then it will start doing the calculation. If anything is wrong, it will show it in red. And remember you have to select your midplane. We create a midplane for the belt as work plane 6. So we click on that one, select it, the belt loop will be sketched onto this work plane 6. So you click OK, everything is good. Then you go to your environment. Sorry, it's running a little bit. Yeah, it's kind of like regenerating that belt loop here. So we have this belt loop. We will go over here, make sure our V belt is, even though it's grounded, but it's still flexible. By flexible, it means like when you do the stimulation, it can be applied with the insert joint, because if it's not flexible, you won't be able to select any of the pulleys. So over here, we will click insert loop, choose the belt, and we have already done here. You could see that this belt joint is from the large pulley to the smaller pulley, and then large pulley to the idler pulley. Then for the second one, it's from the idler pulley to the smaller pulley, the component pulley that we just created. And then we will make sure we have a sliding joint for our cam that need to drive the follower, so it will always follow. So same thing, just insert joint. And then going over here, select the sliding cylinder curve. So this is the one we wanted. So once we set it up, choose from, I'll go in here. So for the first one is the loop of the profile of the cam, and then we choose the second cylinder as our roller here. Okay, apply. Okay. Anyhow, so we have applied all those, and final thing is we need to make sure we have this rotated. So we will go over to our standard joint, find our revolution for this large pulley, and we will go to its property, degree of freedom. We want, it will have the general lock degree of freedom. Please don't do that. It will kind of create some problem. And so degree of freedom of the rotation is, we will edit an imposed motion. Enable this imposed motion, like if you initially started this revolution command, it will be grayed out. So make sure to enable it, choose the velocity, and I set this one as 1080 degrees, but it's actually just like 360 degrees rotated 3 times. So that's what we do for the velocity. Okay, so click OK. Then we will click run or replay the stimulation. Yeah, we just clicked run to let it run till it's 100%. Then we can take a look on how this thing goes as we see it in here. So you can actually see the belt. The belt is probably not really rotating or moving at all. It's just that it's driving. So it drives the pulley. It's just like indicating the pulley is rotating, so it's like driving this thing. This large pulley is driving this idler. It's driving the smaller one in this stimulation. And since we set up all the joints together, it should work like that. And so that's it with the motion in the Inventor and how you do a belt mate in Inventor. So one thing is about whether or not we will know that this belt is just like the same small pulley we had before. I have my small pulley, the part we made from the SolidWorks here. So I kind of make a sketch and then identify the parameter for it. So here I have, where's my parameter? 3 reference parameter. The small pulley's diameter, the outer one, the small pulley base diameter, which is like the pitch and or the groove that we need for the belt to be seen, and then also the shaft, just in case we will need to modify the shaft later on. So once we have this diameter being called out or being assigned, we can go over to our assembly, create a logic, iLogic, go over to the rules, create a new rule. I already created over here as linked parameter. So I will choose the small reference parameter, double click to call them out, and then make them equal to the parameter I had defined in here. So once we have that, we save and run. And let's go over to the module of where we have the belt transmission. And let's do edit using the belt transmission. Over here, our third pulley. We have this pulley properties. We set it to customize, but now we can actually do, we don't really need to have it customized. It will still show the diameter. And for this one, I will go over to the list diameter and then go for the small diameter, which is 250. And that's what we linked from the small IPT. And once we select it, we know that this pulley will have that diameter the same as the small pulley. So we click OK. It's adjusted to that. And let's save everything. I haven't been saving for a while. So now we will have a pulley that's similar to our small IPT from the SolidWorks. And in order for it to look exactly the same, you probably would go over to our transmission, and you see how the group pulley is a IPT, a part file here. So you can go in here and then edit. So now you see that we are in the direct edit mode for this small part. Everything is transparent, and we can draw or select, let's see, let's draw. And let's project the geometry, and then we can, actually not projecting the geometry. What do I want? Yeah. So we can not project the geometry, just draw from center. So what do we have here? Let's identify it as shaft equals. Oops. Alright, it doesn't have that. Oh, because it's in part, so I haven't linked it up yet. So let's just say, yeah, we can just do 2-inch, and then go to model, extrude it out. Let's do cut through all. Okay, and then return, something like that. And so gradually you can modify it into the part that we want, as represented in the small pulley we made before. So that's it for iLogic using the rules, and also for motion study here. So thanks for watching this one. Hope this one helps you out.